Okay, let's take a look at class example problem unit A2, page 8. This is the capillary motion problem due to surface tension. Let's take a look. An open clean glass tube having a diameter of 3 mm is inserted vertically into a dish of mercury at 20 degrees C. How far will the column of mercury in the tube be depressed? Okay. Let's take a look at the equation we're going to use to begin with. This is capillary motion equation. Okay. Where does that come from? Let's take a look at previous page. Alright. So this is the page that you have two different cases of capillary motion. This one is called wetting liquid, typically water. If you insert the glass tube into wetting liquid such as water, due to surface tension, liquid inside of the tube is lifted up by the amount of H. Okay. Now, this is the case that you're looking at as an example problem here. This is called non-wetting liquid, typically mercury. If you put glass tube into the tub of mercury, you are going to depress the liquid by the amount of H. Now this case and that case can be analyzed by the same exact equation, which you need to derive it by taking a free body diagram of the liquid inside of the column. Okay. This is, I believe, the homework assignment, so I'm not gonna do this. I suppose you are going to do this. So by doing this free body diagram and application of force in vertical direction set equal to 0, you are going to end up having this equation called capillary motion equation. So if we get this equation, of course the rest is plug and check, but this is the homework. You must derive this equation by yourself. So assuming that you did, okay, the rest is very simple. You're going to take a look at the table 1.6, which is, again, handout. You're going to find out the property of mercury here. So let's plug in the values. So by looking at the table 1.6, the sigma, this is the surface tension, the force per unit length of mercury is 4.66 times 10 to minus 1 Newton per meter. So this is the surface tension, force per unit contact length for the mercury. Multiplied by cosine of theta, which is contact angle. In case of mercury, this is 130 degrees. This is called non-wetting liquid. Gamma, specific weight of mercury, is 133 times 10 to 3 Newton per meter cube. Let's be careful. Diameter of the glass tube is given. This is a radius. So diameter is 3 mm, radius is 1.5 mm. I convert it to meters. Make sure you stick with the standard units. So if you plug in those numbers, you're going to get meter value, which is minus. Cosine, one side is minus. Minus 3.003 times 10 to minus 3 meter, which means okay. So let's go back to the previous page. So this H if you have a 3 millimeter diameter glass tube inserted vertically into the dish of mercury, you are going to depress the mercury by the amount of 3 millimeter. Okay. What is causing it? It's done by surface tension. It's called capillary motion. Okay, that's it.